Welcome. I'm so glad you can join us on Mission Evolution, where we bring the latest knowledge from today's leading experts to support your evolutionary process. I'm your host, Gwilda Wiyaka. This hour, we'll explore longevity, evolutionary concepts on aging. Aging is a fact of life. It happens to any of us that don't die young. Yet, do we really have to deteriorate as we age? Is there a way to remain healthy, active, and creative at any age? Can we savor the experience of becoming an elder rather than dreading it? What would it take to evolve the way we age into a positive experience? With us this hour to consider this topic is Dr. Sandra Kaufmann. Dr. Kaufmann began her academic career in the field of cellular biology, earning a master's degree from the University of Connecticut in tropical ecology and plant physiology. She received her medical degree at the University of Maryland and completed a residency and fellowship at Johns Hopkins. Presently, she's the Regional Medical Director of Pediatric Anesthesia, South Florida, for Envision Health Care, and the Chief of Pediatric Anesthesia at Joe DiMaggio Children's Hospital. Dr. Kaufmann is the author of the Kaufmann Protocol. Her website, drkaufmannprotocol.com. Dr. Kaufmann, thanks for joining us on Mission Evolution.
I am so happy to be here. I'm looking forward to this discussion.
So you're kind of hitting the world from both ends. You're working in pediatrics, and we're going to be talking about geriatrics today. How did you get interested in geriatrics?
So that's an excellent question. And I don't actually talk about geriatrics. I talk about avoiding geriatrics. And the answer, I really do. As a pediatric anesthesiologist, I think kids are adorable. But the real thing that I've learned from being an anesthesiologist is how drugs and chemicals and molecules affect your cells, and conversely, how your body affects the drugs and chemicals that we put into it. So it's pharmacology, it's pharmacobiology, and it's the idea that we can sort of manipulate our cells to avoid aging and avoid sort of becoming geriatric. The reason that I started doing this is because I am an avid rock climber, and I was hanging off a cliff in my 40s. And I thought, if I don't do something to stop aging, I'm going to die a horribly ugly death falling off cliffs. So I set out on this quest to sort of defy age.
Defy age, isn't that an interesting concept? I think it'd be interesting, if you don't mind, defining aging, because don't we view aging differently now than, say, our indigenous peoples did? They stayed active and part of the tribe well into, some of them over 100. And yet here, when we hit 40, 50, like you say, we start to physically deteriorate. So what's causing that?
So it depends on how or who you are and how you look at aging. Some people define it as loss of function. I can't get down on the floor and play with my grandkids, or I need reading glasses, or my hair is turning gray. I define it as cellular dysfunction because I was a cell biologist. So I look at cells and see that they're not functioning as they should be. And as a consequence, your organ systems don't function as they should. And when you tie all of the organ systems together, it leads to disease. It leads to all sorts of problems that eventually leads to aging. But I took a poll to see what people do define as aging, and it's really interesting. And realizing this is very unscientific, a lot of people said that aging was the idea that they couldn't drink all night and then wake up and go to work the next morning, which is not something that I do, but people in their 30s, they notice aging as well. So it means many things to many people in different walks of life.
What is the physical process of aging? I mean, isn't the body designed to be self-regenerating?
That is the most loaded question I think I've heard in a long time. So no one necessarily, I'm an evolutionary biologist, so no one necessarily designed us, but from an evolutionary biologist point of view, you are supposed to produce progeny, and then it doesn't really matter what happens after that, right? To keep the population going, all you have to do is produce children, get them to adulthood, and then as an old person, you can die because evolution doesn't really care at that point. So what we are talking about is more about personal satisfaction and enjoying life and not deteriorating. So in terms of design, there's no design, but things do fall apart over the course of time. And if you look at cells, you can sort of point out exactly what fails over time. And the good news is in the last decade, we've sort of started to unravel all of these very small issues, and we can sort of defeat them one by one on a cellular level.
So what are you using to defeat them with?
So excellent question, once again. So if you look at the different reasons that your cell ages, you can sort of define these things. So as an example, I break it down into 7 categories, one of which, the first category, has to do with your DNA. And DNA falls apart for various reasons. Your telomeres get shorter. You get something called epigenetic modification, which can be good, but it's generally bad. And your DNA sort of falls apart because the environment is cruel in terms of free radicals and toxins and that sort of thing. So just in the DNA category, you can actually take agents that increase or stabilize the length of your telomeres. You can take positive epigenetic modifiers, and you can take agents that increase the support system of your DNA to minimize DNA damage. And DNA damage leads to cancer, and that's one of the reasons that we age. So if you sort of attack these things piecemeal, you can sort of defeat or minimize aging.
So when you're talking about agents, are you talking chemical agents, herbal agents? What are you talking about there?
So I like to call them molecular agents because everything works on a molecular basis. I do not have a care or concern if something is a natural molecule, a man-made molecule, if we've seen it for centuries, or if we made it yesterday in a laboratory. Everything works in your body from a molecular standpoint. So yes, some of it can come from food, some of it can be absolutely natural, and some of them just isn't. Different people are going to have preferences as to what they decide to use. So what I have done is I've sort of created an encyclopedia of all of the different molecular agents, what they do, how to take them, what they do in each of the 7 categories of aging, so people can sort of be educated and design their own longevity programs, because aging is different for everyone based on their genetics and their lifestyle and that sort of thing.
So we've been talking about what we can add to our system. Are there things that would benefit us if we're looking to slow the aging process to not add to our system?
Well, absolutely. And it's common sense, right? It's all the things that your mother told you were bad for you, probably are bad for you. Being overweight, eating Twinkies, all of the high glucose foods are very, very bad for you. All the high cholesterol type foods are very, very bad for you. Exercising is tremendously good for you if you're going to do something in a positive direction. Obviously, smoking, being around environmental toxins, being in situations where you have increased radiation risk, all of those things are negative environments. And if you sort of take yourself away from those types of things, you're going to just do better.
So that kind of answers my question about why did the indigenous people tend to stay vital and healthy well into their old age when we start breaking down around 40. Our environment has a lot of that stuff in it just by the nature of the way we live, doesn't it?
Of course it does. Of course it does. And
so
I think in the old days, you keep referring to it. I'm not completely convinced that people lived that much longer back then, but they were definitely more active. They ate better foods. Their stress levels were probably different. I'm not sure if they fell off of cliffs or were eaten by tigers. I don't exactly know how they died. Clearly, they probably had the same amount of some of the diseases that we have, but not the ones that are environmentally caused.
Right, and we do have a lot of those now, don't we? Isn't cancer kind of leaning that direction, being an environmental disease?
Cancer is a huge word that means many, many, many things. Cancer basically comes from DNA damage in cells. A cell becomes rogue, and for whatever reason, it then sort of, it's obviously, it's just uncontrollable, and it grows and it metastasizes and it takes over standard body tissues. There are many reasons that DNA breaks down. On a regular basis in any human cell right now, there are 10 to the 5th DNA errors per cell per day, meaning you're kind of in trouble. The good news is that we have DNA repair mechanisms, and we have 4 of them, and they're very, very active. Unfortunately, as you get older, the enzymes don't work as well, and you have more DNA damage. So the increase, you basically have an increased likelihood of cancer. I have no idea what the risk of cancer would have been 1,000 years ago because there's no way to measure it. People just sort of died because they died. We don't know if it was cancer or if it wasn't cancer.
That makes sense. So do we inherit some of this predisposition to DNA damage in the
Oh,
DNA?
of course we do. Absolutely. If you look at anyone's family history, and one of the first things I do when I take care of my clients is you ask about family history of cancer. Clearly, if everyone had the same cancer, there's probably a genetic problem in whatever organ system you're looking at. So if everyone has breast cancer, clearly it could be the BRCA gene or one of the other genes. But if there's a family history of different types of cancer, there's probably either frailty in the DNA itself or a loss of the ability to correct your DNA damage. So something in the repair mechanisms isn't quite right. So depending on these patterns, you can sort of augment your body to do better. For example, there are certain herbs that increase DNA repair mechanisms. So if you know you are prone to this, you can sort of help yourself and reduce relative risk of cancer.
Fantastic. Well, we're just about to go into a commercial break. At the other side of the break, though, I would really like to go further into what can we do to mitigate DNA damage, because it seems like it's something we end up inheriting, whether we want to or not. And then we add to it by our environment. Dr. Kaufmann and I will return shortly, so don't go away. This is Mission Evolution. For more information or to find our past archived episodes, visit www.missionevolution.org. Hello again. This is Mission Evolution, missionevolution.org. We're dedicated to unification and evolution of consciousness. With us this hour discussing evolving our approach to aging is Dr. Sandra Kaufmann. Her website, kaufmannprotocol.com. Sandra, we were getting into one, that there is a genetic predisposition to DNA damage or weakened DNA or not repairing one's DNA. But then you were starting to say that we aren't stuck with that. There's some things that we personally can do to mitigate it. Would you mind continuing with that?
No, absolutely. So I like to think of it as sort of a multi-step process. The first thing is to protect your DNA. We all have risks in terms of free radicals and radiation and that sort of thing. One of the reasons that skin cancer is such a problem is because UVA and B radiation cause DNA damage, right? Maybe up in Canada, it's not such a problem, but down here in Miami, it's quite the problem. So in order to protect your DNA, there's several things that you can take orally that bind to your DNA and sort of cover it. One of my favorite things is actually an agent called spermidine. It is a long molecule. It's a polyamine, and it sort of, it's a long positive chain that sort of fits into the negative groove of your DNA, and it sort of acts as a bubble wrap, and it's known to protect your DNA from UV radiation and free radicals. So that's kind of a really cool thing you can do. The other thing in terms of protecting the structure of your DNA is magnesium. 2/3 of the world, at least the Western world, is magnesium deficient, and magnesium is known to basically protect the structure. So by combining these two things, you just sort of upped the or decrease the likelihood of having DNA damage. So that's useful. Also, in terms of protecting your DNA, are free radical scavengers. Free radicals develop from your mitochondria just because we need oxygen to make mitochondria work. And these free radicals love to destroy DNA. So increasing your free radical scavenging capacity is another way to protect your DNA. And you can do that by many things. One of my favorite agents that does it is something called astaxanthin. And it actually is a natural molecule. It comes from algae. It's extremely low risk. It's in the entire marine system. It makes things pink. So everything from krill to salmon to roseate spoonbills all have astaxanthin in it, and it's extremely protective for your DNA. So that's sort of like the protection category.
That's gives me a feeling of power to know that we don't have to just sit here and deteriorate, that there's things we can do to mitigate it. When you spoke of magnesium, that deficiency, doesn't that also impact the heart and heart attacks and arrhythmia and that sort of thing?
Oh, absolutely. Without a doubt. This is why what magnesium was one of the most common things that people purchase over the counter to sort of help themselves. And what they don't understand is that you're also protecting your DNA. So it is extremely crucial to not be magnesium deficient. You can buy magnesium. There's many compounds. My favorite, however, is magnesium threonate. And the reason it's my favorite, it is the only one that actually gets into your brain. It crosses something called the blood-brain barrier. And that actually is shown to increase hippocampal plasticity, which means that over time, it will make you smarter and or help you not lose your memory.
I can use a lot of that. How about you?
Oh, I take it every day.
Oh, man. Yeah, I hear you. So when we're working with your protocol, you said you take a person's history and see what their family history is like. Do we as individuals look at our family history and kind of target the places that we find weaknesses?
Well, you should. I don't know if people do, but you should. So I break, as I said before, aging into 7 categories, 7 cellular categories, and different disease states or family histories sort of are worse in certain categories. And we haven't talked about the categories, but my last category is what I call waste management. And this has to do with sugar control. And we all know that glucose is pretty bad for you, and it glycates all of your inner structures, and it makes proteins and enzymes and all these things not work. So diabetics in general, because they have increased glucose, don't do as well, right? They have cardiovascular disease, they have neurologic disease, they're more likely to get cancer because glucose is inflammatory. So people that have a family history of diabetes or being pre-diabetic should target that particular category. And the way that I have arranged my protocol is that all of my agents are rated so that you would pick agents, molecular agents to take that are more likely to help you in that category versus other categories.
Now, some of these agents, do you have to have a prescription for?
So the only one that I have on the protocol that you need a prescription for is metformin. Everything else is over the counter. And the reason metformin is on there is just because it's extraordinarily important. It's probably one of the most powerful tools we have in the longevity world. It's extremely inexpensive. It's been on the market for 50 years, so it's very easy to get. Usually you can walk into your primary care office and say, hey, I want to do this. And they give it to most people. Alternatively, there are websites you can go on. There's something called Ageless RX, and you fill out a form and a physician calls you and you can get metformin. So there are many ways to get it because it's extraordinarily benign and extremely useful.
What does it do again?
Oh, it does many things. It's magical. So it is actually an anti-diabetic drug. It lowers your blood glucose level, but it also activates your AMP kinase pathway, and it activates your sirtuin pathways, which are known to be associated with longevity. It changes the type of bacteria that's in your gut. There's what I call good bacteria and bad bacteria, and it increases the good bacteria, which makes you healthier over the course of time. There was a study about 5 or 6 years ago that looked at metformin retrospectively, and they noticed that diabetics on metformin did better than people that were not diabetic at all and not on metformin. So metformin can not only overcome the negative effects of diabetes, but it can help you just live longer in general. So it's an extremely low toxic, high benefit medication.
Which brings us to my next question. Would you please address what is health span versus lifespan?
Yes, very important concept here because people, they're afraid of living long lives because they don't want to be geriatric and infirm for long periods of time. No one wants to be in a wheelchair, unable to breathe and unable to do anything for a long period of time. But that's your lifespan, but that's not your health span. Your health span is how long can you possibly be as healthy as possible. So if you are in your 80s, your 90s, your 100s, 110, and you're just as physically active as if you're in your 60s, then you win, right? So theoretically, you want to increase both, but it was more important to increase your health span than your absolute lifespan.
Yeah, who wants to lay around in a wheelchair, right? There's no
Exactly.
quality of life there. So is physical decline a natural part of aging? We've been talking about the things that create it in our environment, but is it natural to aging to physically decline?
It is. It absolutely is. Very few organisms, of any, live forever, which means that there's absolute decline. It's just a matter of how quickly you are going to decline. The goal, of course, of our project is to decelerate it a lot. Can we decelerate entirely? Probably not at this moment, but that's the plan. But yes, everything falls apart over time. Your collagen falls apart because of glycation, free radicals are a problem. Everything is very additive and cumulative. And the idea is, can you just decelerate it as much as possible?
I know there was a big buzz about the human growth hormone. Would you speak to that?
Sure. So there are many different levels of aging. And one of the reasons when your cells fail, well, let me back up. Cells are like little factories. Then they make everything that your body needs. And of course, they're specialized. Some cells make insulin, and some cells make hormones, and some cells make collagen. They're all very specialized. But if all of your cells are working as well as they possibly can, you're going to make all of the hormones and proteins all by yourself. So if I get people on longevity protocols and their cells are optimized, they never need hormones. If, however, you haven't been optimizing your cells and your cells are failing and we can't get them jump started, then you need to replace the hormones that you couldn't make. And there's lots of hormones. There's growth hormone, all of the female hormones, testosterone for men. So I consider that like part 2 if you failed part 1. So they absolutely have beneficial effects, but it's not the first thing you want to jump to.
So the hormonal replacement is also part of the anti-aging protocol, if I'm understanding you to say, if you can't manage to balance them without replacing them.
That is correct. That is correct. For example, I was just going to say, so for women, I have lots of women on protocols, and we have gone from, a normal age of menopause, middle 40s. I can delay it for about a decade. So eventually they're going to need, estrogen and progesterone replacement. But at the moment, we've delayed that for about a decade. So I think that's really impressive.
And you're saying you've delayed it by a decade through the use of the protocol and other means outside of hormonal replacement.
Absolutely.
Interesting. Does it delay menopause?
Absolutely.
Good heavens. So, with menopause, and we're about out of time in this segment, but with menopause comes a lot of problems, like we don't absorb calcium as well and all of that stuff. So is that why it's part of the anti-aging protocol to keep the hormones rebalanced?
Oh, absolutely. So you go into menopause for many reasons, but the biggest reason is mitochondrial failure. So if you can bolster your mitochondria, and we know how to do that, they're going to keep chugging along and doing all of the things that they did in your 20s, 30s, and 40s. So if you can continue that 50s, maybe even 60s, you're going to delay menopause, delay the failure of the estrogen, and delay all of the sort of cataclysmic events that happen thereafter.
Well, we're going to have to pick up on those mitochondria on the other side of a break here. Dr. Kaufmann and I will return to our discussion shortly, so you stay right there. This is Mission Evolution. For more information or to explore our archived episodes, visit www.missionevolution.org. Welcome back. This is Mission Evolution, missionevolution.org. Our guest this hour is Dr. Sandra Kaufmann. We're speaking about longevity. Her website, kaufmannprotocol.com. Sandra, we were just getting into speaking about the mitochondria, and not all of us know what the mitochondria is. Would you mind telling us what it is?
Absolutely. So if everyone's puts on their thinking caps and thinks back to the 5th grade, you remember that little diagram of a cell. And within that, there's a jelly bean looking little organelle with a double membrane and a little squiggly line on the inside. And that, in fact, are these little organelles called mitochondria. And they are extraordinarily important because they create all of the energy that your cell needs. The number of them is within any given cell sort of depends on the type of cell that it is and how much energy that you use. In any one given cell, you can have anywhere between 2, 3, 5 to 500,000. And interestingly, oocytes have the most mitochondria. They have like 500,000 before they become little eggs and then hopefully little people. So one of the reasons that people go into menopause is mitochondrial failure. I like to think of it as the canary in the coal mine. If you start going into menopause, all of your mitochondria are failing throughout your body. And so it's time for sort of emergency rehab of your mitochondria.
Isn't that interesting? What age can we expect to go into menopause if we're maintaining ourselves for longevity?
So the range is somewhere between 43 and 50 some. Probably the vast majority is 48, 49. As I said, my clients have gotten far beyond that, which is very, very exciting. But you can't wait for the symptoms to start because then they're sort of performing CPR on your mitochondria. You sort of have to know that it's coming and sort of be prophylactic. We know that mitochondria fail for very specific reasons. We know, for example, that after the age of 40, most people are deficient in nicotinamide. We know that after 40, your mitochondrial transition pore starts misbehaving. We know that your free radical scavenging capacity starts to drop. So if you sort of look at all of these things and then treat them accordingly, you can theoretically avoid mitochondrial failure.
And it's not like menopause is subtle. I mean, we have plenty of signs that it's up and coming, don't we?
Well, and the other thing is there have been billions of women that came before us. So it's not shocking. We know it's coming, prepare accordingly.
So changing gears a little bit, how much of aging is a mindset that we kind of set ourselves up with? Oh, I'm getting older, and we tell ourselves that story all along. And so ergo we do.
That is an excellent question. And I don't know what the percentage would be. It probably depends on your genetics. That being said, if you are an upbeat person and you're enthusiastic, you can certainly keep your body moving. You can certainly keep exercising. You can certainly stay away from pathogens. You can certainly do all of the right things. And that will obviously be better off than if you had a negative way of looking at things. On the other hand, you can't positively influence the way your cells act by being positive. You just can't. You can't keep your body from being glycated or your DNA from being injured or your mitochondrial from failing. So the good news is if you combine some sort of longevity protocol with a positive outlook, then it's a double win, right? So that's how you're going to get to 120 and 130, et cetera.
Well, wouldn't the mindset of, oh, I'm just going to get old, I'm getting old, wouldn't that keep us from engaging the protocol, from engaging any other options?
Oh, without a doubt. Having a negative outlook on aging is absolutely not going to do you any favors because you're going to give up on things. You're going to give up on going to the park to exercise. You're just going to be sedentary and your brain is going to be inactive. And as we know, muscle inactivity leads to atrophy. Atrophy leads to further decline and frailty. Without a doubt, having a good attitude versus a bad attitude is definitely going to affect longevity.
So you've mentioned the 7 tenets. Would you mind going into those for us?
Oh gosh, yes. This is going to bore everyone to death now, but I will go through them quickly, I hope. So tenet 1 is DNA failure. And we talk about DNA alterations in terms of, I think I said this before, telomere shortening, epigenetic modification, and structural integrity. 2 is mitochondria, and we sort of briefly touched on that. 3 is what I call pathways, the sort of gene to protein pathways that promote longevity, such as your sirtuins, your AMP kinase pathway, and then the mTOR pathway. 4 is what I call quality control, and this is where you have DNA and protein repair mechanisms and something called autophagy, which is cellular recycling. 5 is your immune system. Over the course of time, everyone becomes more systemically inflamed. Your immune system fails you, so vaccines don't work as well, and you're more likely to get leukemias and lymphomas. Item 6 has to do with individual cell requirements, such that you want to promote stem cell health. You want to get rid of senescent cells, and red cells are different than liver cells. So this just sort of caters to the individual cellular requirements. And then the last tenet, 7, is waste management. As I sort of alluded to, it's glucose management. We all become glycated over the course of time, and that has horrific ramifications. And then there's something called lipofuscin accumulation. So in long-lived cells, unrecyclable gunk, as I call it, sort of gets stuck in the back of cells. And as you get older, especially your brain cells become filled with lipofuscin, and then you just can't think very well. So in a very small nutshell, those are the 7 reasons that you age.
So when do we need to start worrying about aging? When do we need to start taking up the protocol?
35.
Doesn't help if we do it before and it's later you're doing resuscitation, right?
No, that's absolutely true. So most cellular systems start failing by 35. Granted, life is a bell-shaped curve. So some people are going to be earlier, some people are going to be later. And again, it depends on what your physical state is. If you're 400 pounds versus if you're thin, if you're active versus if you're a couch potato, if you're a smoker versus not, drinker versus not, everyone is going to age differently. But overall, in general, you should start thinking about it by the time you're 35. So by the time you're truly a geriatric, you're playing a very much a catch-up game rather than a proactive game. So when you first said taking care of geriatrics, I don't really take care of a whole lot of geriatrics because people these days are extremely proactive and they want to just get on the ball as early as possible.
That's the good news, isn't it? Because we have historically, well, in this last couple generations, we've only honored the young and the new, and totally missed the wisdom and the people that are living longer gather. And I think that right now in society, don't we need that wisdom?
Oh my gosh, we absolutely need that wisdom. And wouldn't it be fantastic to have older people that were extremely healthy, extremely vibrant, part of our social world, just having so much knowledge and wisdom? I mean, everyone would win and benefit from that. Because right now, the people with the knowledge, they go home and they don't do anything, and we lose it. And I absolutely think that society as a whole would absolutely benefit from keeping people as well as long as possible to sort of benefit from their experience.
It's amazing that we're starting to look at that now, finally. And I think everybody out there is looking for answers. I think we're kind of in trouble right now, and they're looking for people with some wisdom.
Oh, I absolutely agree. I absolutely agree.
Yeah. So that wisdom can't be passed on, though, if we're deteriorating mentally. What are we looking at with Alzheimer's and that sort of thing? And how can your protocol help with that?
So I like to think that it can. We absolutely don't have all of the answers to Alzheimer's disease, but we do know that neurologic degeneration gets sped up with high glucose levels, and it gets sped up with high oxidative issues. The brain uses 20% of your body's glucose, but it's only 2% of the mass, and it uses 20% of the oxygen. So it's very hard to protect your brain. Thus, we need to take agents that get through the blood-brain barrier, that reduce the glycation issues and reduce the oxidative stress. And these absolutely exist. And there's also a variety of agents that increase neuroplastic plasticity. We mentioned magnesium threonate, but there are a variety of ones that get in and increase the health of your brain cells. So you can absolutely be proactive in trying to stave off neurodegenerative disease.
So you've mentioned it several times, the blood-brain barrier. What is that, and how do we get beyond it?
So what the blood-brain barrier is blood vessels obviously have to get to your brain. But around each blood vessel, there's a special set of cells with very tight junctions, and it serves to keep toxins out of your brain. And so in general, and it's an extremely useful barrier. Unfortunately, it also keeps out the things that we want to get into our brain. So in general, it allows in very small molecules, lipid soluble molecules, and things that fit into very specific transporters. So when we are trying to get things into our brain that are beneficial, we sort of study the blood-brain barrier permeability factor to make sure it's going to help us not only all over our bodies, but in our brain as well.
So there are certain things that we do need to get into our brain. And do we know what those are, or are we running the risk of getting something there that isn't going to do us any favors?
So that's a very good question. So what I do, I look at all of these agents to see, and it's mostly in mouse models, to see if agents do get through and how beneficial they are. And we can measure ratios of systemic versus brain tissue levels. And we do know that some things are helpful and some things are not. We do know that spermidine, for example, gets into your brain, as it's extremely useful for brain protection. We know that magnesium threonate, as I mentioned, in terms of free radical scavenging, there's a wonderful chemical called andrographylide that comes from a plant. It is a water-soluble free radical scavenger, and it's known to protect the brain. So
we're going to have to talk about a little more on the blood-brain barrier on the other side of a break. Dr. Kaufmann and I will be back shortly, and we're going to continue this great discussion. So don't go away. This is Mission Evolution. For more information or to find past archived episodes, visit www.missionevolution.org. Welcome back. This is Mission Evolution, bringing together gifted people of service to the world. And speaking of gifted people of service to the world, this hour we're sharing thoughts with Dr. Sandra Kaufmann. Her website, kaufmannprotocol.com. Dr. Sandra, we were talking about the link between the blood-brain barrier and trying to get things across that we do need in there without violating it so things don't go in there. I've heard a lot of talk that essential oils, where it comes in through the oral factory, can cross the blood-brain barrier and be fairly beneficial. Are there any of those in your protocol?
There really are not. I am not an aficionado of the essential oils. I think some of them probably are quite beneficial. I sort of focus more on molecules that you would take systemically. So that sort of discludes that. So I apologize for my lack of knowledge.
Not a problem. You don't seem to be lacking much knowledge right now. Okay. In fact, your wealth of knowledge. I appreciate you being on the show. The protocol that you're talking about, is it a lot of oral medication? Are there any injections?
No, I wanted to make this as simple as possible. So it is all oral, and it's a mixture of, there's obviously just one medication, and then it's pretty much everything else is over the counter. So they are technically called supplements, but I call them molecular agents, but they are equally as potent as any drug you would theoretically take if you use them correctly. So I don't want people to get the idea that this is some sort of crazy supplement program. It is scientifically designed to combat very specific cellular problems.
How much of the cellular problems developing is from a lack of these particular elements?
So that's a good question. Some things are because you don't have enough of them, right? You're deficient. Some things you benefit from having a lot more of, and some things your body has never seen before. So, for example, vitamin C, if you are deficient, clearly you're going to get scurvy, right? The old pirates of the day, they all had scurvy because their collagen was falling apart. In today's world, actually, people do become vitamin C deficient. When you have colds, you use it up very quickly because it's a free radical scavenger that your white blood cells need to combat viruses and such. So I would imagine in the COVID world right now, there's a lot of people that are vitamin C deficient and they don't know it. On the other hand, just being vitamin C sort of equivalent isn't going to help you not age. Taking extra vitamin C actually does. So it's actually in book 2 because it does amazing things. It's a coenzyme in many very special enzymatic processes that sort of fail over time. It does help you make more collagen and better collagen, which is one of the things that fails over time. And it just does a plethora of things around the body such that more, in fact, is better when it comes to vitamin C.
So if we're taking these vitamins, is there a point who I interviewed one doctor, he says, you're just making expensive pee. Is there a point at which we're kind of building up a toxicity level of them, or at very least wasting them?
So it just depends on what you're taking. A lot of people love to take all sorts of crazy stuff. And to a certain extent, he's right. We are making very expensive pee. That being said, if you take targeted agents, then it's not expensive pee. So as an example, a lot of people love to take multivitamins. And in fact, you do need multivitamins because a lot of people are micronutrient deficient. You don't need as much as they tell you that's on the package, because you're absolutely right. It is expensive pee. On the other hand, you do need things that you don't have enough of. You need sirtuin activators. You need nicotinamide. You need spermidine. You need fisetin. You need to battle all of the things that your body can't battle all by itself with regular nutrition. One of the things we haven't sort of touched on, which I'm a little bit obsessed about, is something called senescent cells. The older you get and the more areas of pathology your body has, cells sort of go haywire and they change in morphology and they start exuding inflammatory cytokinins. So they're just very pathologic. And what they do is when one cell becomes pathologic, it sort of affects all of the other cells in the area and you have a whole bundle of senescent cells and they're all very, very inflammatory. So how do you get rid of them? The answer is something called quercetin or fisetin. Quercetin comes from onions and fisetin comes from strawberries, but you couldn't possibly ever eat enough to reach appropriate levels. And so where, yes, it is a little bit pricey, there's no other way to get rid of senescent cells. So that is money well spent and it's not expensive pee.
So let's talk a little bit about absorption, because that's another thing that I hear a lot of, is that some of these things we can take, but they're not in a form that we're really absorbing them.
Right. So in the science world, we call that bioavailability. And you're right. Some agents go through your GI tract and many things can happen. It can get broken down and absorbed and then metabolized very quickly, which limits its bioavailability. Or sometimes it goes to the bacteria in your gut, they metabolize it to something else, and then you absorb those metabolites. And there's usually a percentage that we know gets into your body and is very efficacious. And it can be anywhere between something very low, 1, 2, 3, 4, 5%, up to 70, 80%, depending on what agent you are looking at. For molecules that are extremely beneficial, that have low bioavailability, a lot of companies right now are specially packaging them to make them more bioavailable. They put them in something called nanomyceles. Some of them are sort of in special encapsulated formulations. So when you read these bottles and it says high bioavailability, that essentially is answering your absorption question.
So are there certain things that we do have difficulty absorbing and we're kind of wasting our time if we don't find the ones that are extremely bioavailable?
Oh, absolutely. My favorite example is curcumin, right? Curcumin is an extremely potent anti-inflammatory. It is amazing. It really is amazing. People say, oh, I take turmeric. And the problem with turmeric is that only 1 to 3% of turmeric is actually curcumin. So people take straight curcumin, but it does not get into your body and it gets dissolved really easily. So the half-life is extremely short and it's good for about a half an hour to an hour. So that's kind of pointless. But if you put it in a nanomycele, you can up the bioavailability by 280 some times, which makes it actually usable. So let
me interrupt you. What's a nanomycele?
It's just a really, really small encapsulated lipid that has stuff inside of it. It's like a specialty delivery system.
Okay.
There's a company down here that puts very important things in nanomyceles, and I think their products are just astounding. So I won't take regular curcumin. I take nanomycele curcumin. I don't take regular quercetin. I take mine in these little capsules. So again, you're right, absolutely right. The bioavailability is just extraordinarily important.
And I would suspect that you have that all covered in your book.
Oh, yes, I do.
I didn't think you'd overlook that part.
No, it's quite important.
So, Dr. Kaufmann, what is your mission?
to live as long as possible, as well as possible.
And apparently to help
That's
others do
it.
the same, right?
So I was actually very selfish when I started this project, and people thought I was absolutely nuts. But the goal was actually to be able to live my life as well as possible. And as a consequence, I would love to make other people be able to do the same thing. On the other hand, I don't want to sell anyone anything. I don't want to be seen as the doctor that says, here, this is important, buy my product, because I don't want to be seen as a swindler, a shyster. My goal is to educate people so that they can do what I'm trying to do. I'm happy to help anyone along. I give free advice via email all the time. But I just think that decreasing the risk of disease and making people active and better will help all society, including myself, which gets back to the whole point of, yeah, I want my life to be better.
So that brings us back to the evolutionary process, that if you can help people do this, if people can help themselves with it, we can really evolve as a culture with the people that are getting older and having all this wonderful wisdom and information, still able to impart it and care.
Oh, absolutely. Without a doubt.
So what's your vision for elderhood in the future, if this protocol and people start really paying attention to this sort of thing? What's your vision for elderhood in the future?
Well, I think it's going to be bimodal. I think that the people that buy into this are going to have amazing lifestyles. They're going to be jetting around the world, 80s, 90s. No one's going to say, oh, I can't do that, I'm too old anymore. It's going to be a population of people that are just well off because they've worked, instead of 40 years, they've worked 60, 70 years. Their brains are still active, their bodies are still active, they're contributing to society, and it's just an incredibly amazing place to be. On the other hand, there's going to be people that don't buy into this, and they're going to be degenerative and they're going to be overweight. And I just think you're going to see a split in society of the people that elect to invest in longevity and the ones that don't. And the good news, I think that anyone listening to your show is going to be on the Let's Go Longevity team, and we'll have fantastic lives.
Oh, that's a beautiful vision, and one I share. So we are just about out of time. People can find your book on your website, yes?
That is correct. And it is on Amazon. Kaufmann Protocol, Why We Age and How to Stop It. That is book one. It has been out for 3 years. So it's a little bit out of date. Book two is going to be coming out probably within the month. We're working on the last edits. So hopefully there'll be more information very soon.
Fantastic. Get back on the show when the next one comes out.
Would love to.
Unfortunately, we are out of time, Dr. Kaufmann. Thank you so much for coming on the show and sharing your wisdom. Our guest this hour has been Dr. Sandra Kaufmann. She's the author of Why We Age and How to Stop It, and creator of the Kaufmann Protocol. Her website, where you can find out all about her, is kaufmannprotocol.com. This has been Mission Evolution with Gwilda Wiyaka. For more information or to enjoy past archived episodes, visit www.missionevolution.org. Please be sure to join us next time as this mission continues, bringing information, resources, and support to our rapidly evolving world.